Okay, we're going to start back up by completing the square. I'm just going to go through the algebra side of it. I might create another video that actually explains why solve by completing the square works and kind of give you the visual for it. But right now we want to write the equation in this form. Ax squared plus bx plus something is equal to c plus something else. We want to move that c to the other side because we need to find the value of c that actually works to complete the square. So the first thing really is to move the c to the other side and then divide by your leading coefficient. So we're going to do that on part A here. We're going to subtract the 7 to the other side, kind of get it out of the way. And then we're going to divide by 4. So that'd be x squared minus 2x plus blank is equal to negative 7 fourths plus blank. And so once again, I'm just really going through the algebra side of it. We'll maybe create another video to get into all the y's, but you take half your middle term. So take half this middle term and you square it. So half of negative 2 squared is negative 1 squared, which is 1. That's what completes the square. So plus 1 plus 1. That will now be factorable. It's a perfect square trinomial. So it can be factored into a binomial squared. So x squared minus 2x plus 1 factors x minus 1 squared. And then you take negative 7 fourths plus 1, which would be negative 3 fourths. And now that you have the binomial squared, you can square root both sides. So we'll take the square root of this side, square root of this side. We have x minus 1 is equal to the square root of negative 3 fourths. So that'll be the square root of 3 over 2i because of the square root of a negative 3. And it's actually plus or minus those two. And then you add 1 to the other side, so you get x equals 1 plus or minus the square root of 3 over 2i. And there's a degree of 2, so that's why we have two solutions. So squeeze the brackets in there, and there you go. So that's how you complete the square. Let's do one more example with this. On this next one here, it's kind of already set up for you in terms of your c value. So you're ready to go. I am going to put my blanks in there. X squared minus 7x plus blank is equal to negative 21 plus blank. So once again, you take half your middle term, so negative 7 halves, and you square it. So that would be, and don't write them as decimals, leave them in fraction form. So that would equal 49 fourths. So that's what we will add to both sides. Is 49 over 4. 49 over 4. Now that means you can factor it. But it's a fraction. That's okay. When you take half your middle term and square it, half your middle term is what goes in your binomial. It's always x minus half. Can't seem to make a 7 here. Your middle term. So if you think about it and you distribute this out, 7 halves times 7 halves is 49 fourths, and if you add 7 halves plus 7 halves, you get 14 halves, which is 7. So it always works out. And then this negative 21 plus 49 fourths, you can find a common denominator. You can plug it in your calculator if you want to. But what you'll get is 35 over 4. Now you take the square root of both sides. So that's x minus 7 halves is equal to the square root of 35 plus or minus the square root of 35 over 2. Add the 7 halves to the other side, and so you will get x equals 7 plus or minus the square root of 35 all over 2, and once again, being a quadratic, you get two solutions there. So there is how to solve by completing the square. That might be one that we need to work on in class a little bit if you're unfamiliar or uncomfortable with it. The last method we're going to learn is solve by the quadratic formula. We're going to talk a little bit more about this one as well in terms of what's called its discriminant. So the quadratic formula, if you remember your song, you can sing it. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Once again, maybe in a separate video, I'll show you where the quadratic formula comes from. If you've never seen that, I think it's important to know. You just solve the general form of a quadratic equation, ax squared plus bx plus c, using completing the square. So once again, maybe in another video, I can show you why that works. The discriminant is used to determine the number and nature of the roots. If b squared minus 4ac is less than 0, we already dealt with some of those things, where it was less than 0 and you had a negative. What kind of roots do you get if that happens? Well, you get two complex roots, alright, two imaginary values there. If you have b squared minus 4ac is equal to 0, alright, you get a plus or minus 0, you don't have two solutions anymore. You have one rational root. And then if it's greater than 0, you kind of have two possibilities. You're going to get two real roots if it's greater than 0, but if it's perfect squares, we can be more specific and we'll actually get two rational roots. So if we have something like the square root of 16 or 36 or something like that, we'll get two rational roots compared to just any two real roots. So we have an idea of what our solutions are going to be before we ever really get started if we want to identify what that b squared minus 4ac is. It's the value underneath the square root. So we're going to do a couple of these. I'm not going to do all of them, but we'll do a couple of these here. First one, x squared minus 2x minus 35 is equal to 0. You set it equal to 0 once again when y is equal to 0. You identify what your values are. So a is equal to 1, b is equal to negative 2, and c is equal to negative 35. Now you don't necessarily have to write those down, but that's what you're going to be plugging into your formula. So x is equal to the opposite of b plus or minus the square root of b squared, and since b is a negative 2, the negative 2 is being squared, minus 4ac, and then all of that is being divided by 2a. And so a lot of people like the quadratic formula. It works all the time. It's really just a matter of simplifying the expression. So we'll just go ahead and start here. Negative opposite of negative 2 is 2, plus or minus negative 2 squared is 4. And then when I do this last part, because this is where the part some people get confused, the minus 4, I treat that as a negative sign, so I just do all three. Negative 4 times 1 times negative 35. So negative times negative is a positive, so that's going to be positive 140. So it'll be plus 140 divided by 2. And then we get 2 plus or minus the square root of 144 over 2. So the discriminant is 144. It's not the square root of 144, it's just 144. B squared minus 4ac is equal to 144. Well, if we go back and look at what we said, it's greater than 0, and it's a perfect square. So we're going to get two rational roots, which really are two nice numbers. The square root of 144 is 12, so we have 2 plus or minus 12 over 2. And you need to write that out. What are my two solutions? 2 minus 12 over 2, and 2 plus 12 over 2. So we get negative 10 over 2 is negative 5. 12 plus 2 is 14, divided by 2 is 7. So our answer is x equals negative 5, comma 7. And so that's the quadratic formula. That's how you can explain the type of roots that you get with that. Let's do one more of these though. Let me see which one I want to do. Let's go actually with C here. x squared minus 10, or sorry, x squared equals negative 10 minus 8x. So let's get these in the correct order first. X squared plus 8x plus 10 is equal to 0. So if you want to pause it and go ahead and practice it yourself first, that might not be a bad idea. I'm going to go ahead and get started. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So that's negative 8 plus or minus the square root of 64 minus 40 over 2, which is equivalent to negative 8 plus or minus 64 minus 40 is 24 over 2. So now you need to simplify the square root of 24. Do not divide until you simplify that square root of 24. So square root of 24 simplifies to 2 square root of 6. And then at this point you might be done, it just depends. You need to look to see if your two terms on top can be simplified by your denominator. So in this case they all have a common factor of 2, so you can cancel that out. So it would be negative 4 plus or minus the square root of 6. So your final answer is x equals negative 4 plus or minus the square root of 6. And so once again your index, or sorry, your degree was 2, so you got 2 solutions there. And your discriminant on this one was 24. So once again, going back, it was greater than 0, but it wasn't a perfect square, so you get 2 real roots or 2 irrational roots. So that's the other way to solve quadratics. And once again, completing the square and the quadratic formula work for everything. So let's just do a quick rundown of what method you would want to use, because you guys are going to get to pick and choose this. We've already learned how to solve quadratics. I'm just doing a refresher for you. You're going to have the choice as to what you want to do in terms of solving quadratics. So once again, maybe just pause the video for a second, go through this list, think about what way you would solve each of these problems, and see if it kind of matches up to what I was thinking as well. So go ahead and pause it, and then come back and check. Alright, the first one I would have factored. You could divide by 2, and it would leave you with something that would be factorable in terms of x squared plus x minus 30. The second one, I would have chose square roots, because you can add the 20 and just go ahead and take the square to both sides. The third one, completing the square, I like that method. It can't be factored. Your middle term is even, so it's easy to complete the square when your middle term is even. And I should also let you know that the a value is 1. So both of those things occur when completing the square is easy. Quadratic formula doesn't factor nicely. Completing the square, too much stuff going on. And then the last one, it seems like we always struggle with this last one, but this last one is a factoring one, because you can factor out the value of x, and then you can go ahead and solve. So that is the rest of the video on solving quadratics. We will next move on to polynomials.